A is called as the base and n is called as the index, or it is also called as power, or it is also called as an exponent. A to the power of m is a into a into a m times, again a into a into a m times. A plus b into a minus b is nothing but a square minus b square. A square minus b square formula is a plus b into a minus b. Hello dear students, welcome to this session of basic mathematics class. I am Mr. Niranjan, faculty, Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Today in this session I am going to take very important chapter, that is chapter number 3, theory of indices. Before going to exact chapter, let us know regarding the weightage for this chapter. So totally you will get 4 marks from this chapter. Very simple chapter. So one question 1 mark and one question from 3 marks. So here one question is from 1 mark and one question from 3 marks. Totally you will get 4 marks. That is one question from 1 mark, one question from 3 marks, 2 questions. So totally 4 marks. So the weightage for this chapter is only 4 marks. That is 1 mark plus 3 marks, that's equal to 4 mark is the weightage for this chapter. Now in this session we are going to discuss regarding the laws of indices and the problems based on laws of indices. That's it. Okay. Now let us come to the introduction. What is an indices first? The basis of indices is important for many calculations. So therefore in this section we are going to discuss regarding the laws of indices and the problems based on laws of indices. Now let us know regarding the meaning of a to the power of n first. What is the meaning of a to the power of n? You might have been studied a square, a cube, a to the power of 4, a to the power of 10. So in general a to the power of n means if a is any real number and n is a non-zero positive integer, then a to the power of n can be written as a into a into a into a etc. n times, that is n factors. If a is repeated n times or n factors, then a into a into a into a etc. up to n terms is nothing but a to the power of n. So here a is called as the base and n is called as the index, or it is also called as power, or it is also called as an exponent. So for example, let us consider a cube. A cube means a into a 3 times. So if you multiply a 3 times, you will get a cube. Similarly, a to the power of 5 means a into a into a into a, how many times? 5 times will give the value of a to the power of 5. That's it. Okay. In general, a to the power of n means just multiply a into a n times will give the. So here a is called the base and 5 is called as the power, or it is also called as the exponent, or it is also called as an index. Okay. Now let us come to the laws of indices. So based on this we have few laws, that is called laws of indices. Let us know regarding the first law. If a is any non-zero real number and m and n are two positive integers, then a to the power of m into a to the power of n is equal to a to the power of m plus n. A raised to m into a raised to n is a to the power of m plus n. Now let us consider the proof. A raised to m into a raised to n, LHS. A raised to m into a raised to n. A raised to m means a into a m times. A to the power of n also a into a n times. So a to the power of m can be written as a into a m times, and a to the power of n is nothing but a into a n times. So therefore this is nothing but a into a m plus n times, a m times and a n times. So this can be written as a into a etc. up to m plus n times. So therefore this can be written as a to the power of m plus n. So what is the conclusion? Therefore a to the power of m into a to the power of n is always equal to a to the power of m plus n. Now suppose similarly a to the power of m into a to the power of n into a to the power of p into a to the power of q. Number of terms are there. If the bases are same, we can add the powers. A to the power of m plus n plus p plus k plus etc. So that is, if a to the power of m into a to the power of n into a to the power of p means this cannot, if bases are same, we can add the powers m plus n plus p If number of terms are there, etc., we can write a to the power of m plus n plus n plus p, etc., terms plus k. That's it. Now, let us come to the second law. What is the second law? If a is any non-zero real number, m and n are any two positive integers, then a to the power of m by a to the power of n is equal to a to the power of m minus n if m is greater than n, or 1 over a to the power of n minus m if n is less than m. This is very important theorem, law. A to the power of m by a to the power of n is a to the power of m minus n if m is greater than n, or 1 over a to the power of n minus m if m is less than n. Now, let us come to the case 1, case number 1. In first case, if m is greater than n, if m is greater than n, what is to prove? Given a to the power of m by a to the power of n. Okay. Now, this is nothing but a to the power of m means a into a, etc. How many times? M times, divided by in the denominator a to the power of n means a into a, etc. How many times? N times. So, this is nothing but in the numerator a to the m times, in the denominator n times. So, therefore, this can also be written as, this is also equal to a into a, etc. In the numerator m, in the denominator n, therefore, this can be written as m minus n times. So, a into a, etc. m minus n times. This is nothing but a to the power of m minus n. So, what is the conclusion? Therefore, a to the power of m by a to the power of n is equal to a to the power of m minus n if m is greater than n. If m is greater than n, a to the power of m by a raised to n is a to the power of m minus n. That's it. Okay. Now, case number 2. What is case 2? If m is less than n, if m is less than n, what is to prove? To prove that a to the power of m by n is equal to a to raised to m by a raised to n is a to the power of n minus m. Now, take this, a to the power of m by a to the power of n can be written as a to the power of m means a into a, how many times? M times, divided by in the denominator a into a n times. Okay. Now, since here m is less than n, so therefore, this can be written as 1 over a to the power of, since n is less than m, therefore, this can also be written as 1 over a to the power of n minus m. That's it, 1 over a to the power of n minus 1, since m is less than n. So, therefore, we can write a to the power of m by a to the power of n is also equal to 1 over a to the power of m minus 1, where m is less than n. That's it. M is less than n. That's it. Okay. That is like this. Suppose if it is like this, a to the power of 4 divided by a to the power of 5. So, here this is m is less than n. M is 4, n is 5, m is less than 4. Here 4 is less than 5. So, we can write this as a to the power of 5 minus 4, right. That is nothing but a to the power of 1, that is 1 by a. So, similarly, if n is less than m, here a into a m times by a into n times can also be written as 1 over a to the power of n minus m, where m is less than n. That's all. So, therefore, so a raised to m by a raised to n is equal to a raised to m by a raised to n is a to the power of m minus n if m is greater than n, 1 over a to the power of n minus m if m is less than n. That's it. Okay. Now, let us come to the next law, third law. So, what is the third law here? If a is any non-zero real number, m and n are two positive integers, then prove that a to the power of m whole raised to n is equal to a to the power of m into n. A raised to m whole raised to n can also be written as a to the power of mn, a to the power of m into n. Okay. Now, let us take a to the power of m. A to the power of m whole raised to n means a to the power of m is multiplied n times. So, a raised to m whole power n means a raised to m into a raised to m into a to the power of m, etc. How many times? N times. A to the power of m is multiplied n times. Okay. So that means this a to the power of m is nothing but a into a, etc. m times. Again into a into a. Again this is m times. Right. A to the power of m is a into a m times. Again a into a m times. Okay. See here. A to the power of m is a into m times. Again a to the power of m. A. So etc. How many times? The last is n times. So that means here this is the multiples of a into a m times. This is also the multiple of a into m times, a into m times, etc. etc. The last term is n times a into a. Okay. Now what is this equal to? Since this is the product, therefore this can be written as a into a. How many times? Mn times. That's it. All see here a into a m times, a into m times, a into m times. So etc. n times are there. All a into a or how many times? That is nothing but m into n times. So this is nothing but a into a mn times is nothing but a to the power of mn. That's it. Okay. A to the power of mn. So what is the conclusion? Therefore a to the power of m whole raised to n is also equal to a to the power of m into n. That's it. That is the proof. Very simple. See here, very simple concept. What is to prove? A raised to m whole raised to n is a raised to mn. So let us consider LHS a to the power of m whole raised to n means, so a raised to m is the multiple of n times. So a raised to m is multiplied n times here. A raised to, what is a square? A into a. What is a cube? A into a. So what is a to the power of n? A is multiplied n times. Instead of a, it is a raised to m. A raised to m into a raised to m. A raised to m is multiplied n times. Okay. Now what is the meaning of a to the power of m again? A to the power of m means a is multiplied m times. A into a m times. Again this is also a into a m times. This is also a into a m times, etc. The last terms are n times. N terms are there. Now a into a m times, a into m times, etc. The last term is n times, can also be written as all a into mn times. So that is nothing but a to the power of mn. So a raised to m whole raised to n is equal to a to the power of m into n. That's it. Now let us come to the next concept. Very important concept. If a is any non-zero integer, then a to the power of 0 is always equal to 1. A to the power of 0 is always equal to 1. If a to the power of 0, x to the power of 0, b to the power of 0 is always equal to 1. Let us consider, for example, 2 to the power of 0 is 1, 3 power 0 is also equal to 1, 1 by 2 to the power of 0 is also equal to 1. Okay. These are the example. A raised to 0 is equal to 1. Right. Next, suppose if a is any non-zero integer and m is a positive integer, then a to the power of minus 1 by m can also be written as a to the power of plus 1 by m. A raised to minus 1 by m is also equal to 1 over a raised to plus m. So let us consider, for example, x to the power of minus 4 can be written as 1 over x raised to 4. 3 to the power of minus 2 can also be written as 1 over 3 square, or a to the power of minus 7 can also be written as a to the power of plus 7. That is, so if a is any non-zero integer and m is a positive integer, then a to the power of minus m is also equal to 1 over a to the power of plus m. Okay. Now suppose if a is any non-zero integer, p and q are positive integers and q is not equal to 0, then qth root of a to the power of p is also equal to a to the power of p by q. The qth root of a power p is equal to a to the power of p by q. So that is qth root of a to the power of p can also be written as, a to the power of p. So the square root means, square root of 2 means 2 to the power of 1 by 2. Cube root of 2 means 2 to the power of 1 by 3. Similarly, qth root of a to the power of p means 1 by q. So this can be written as a to the power of p by q. That's it. So Qth root of a to the power of p is also equal to a to the power of p by q. Let us consider, for example, fifth root of 3 square. Fifth root of 3 square is nothing but 3 to the power of 2 by 5. Suppose sixth root of x to the power of 7. This can also be written as x to the power of 7 by 6. That is the meaning. That's it. Okay. Now, let us come to the next simple problems based on this. Simplify 5 to the power of 5 raised to 0 plus 5 square whole raised to 0. Very simple problem. Since we know what is 5 to the power of 0 is 1, because a raised to 0 is equal to 1. So, this can be written as 5 to the power of 1 plus this is 5 square. What is 5 square? 5 square can be written as 25 to the power of 0. 5 raised to 5 to the power of 1 is 5 plus again 25 to the power of 0 is always equal to 1. So, this is 5 plus 1 is equal to 6 is the required answer. That's it. Okay. Let us come to this problem. 9 by 4 whole to the power of minus 3 by 2. 9 by 4 can be written as 3 by 2 whole square whole raised to minus 3 by 2. So, if you want, you can write 3 by 2 whole to the power of 2 into minus 3 by 2. This 2 and 2 gets cancelled. 3 by 2 whole raised to minus 3. And since you know a raised to minus m is also equal to 1 over a raised to plus m, 1 over 3 by 2 whole cube. 1 over 3 by 2 whole cube. Okay. So, if you want, you can simplify this. Okay. So, this can be written as 1 over 3 cube. 3 3s are 9, 9 3s are 27 divided by 2 square is 8. Take this to the numerator. This can be written as 8 divided by 27. That's it. Okay. Or you can also simplify like this. Or this can be written as or. 9 by 4 can also be written as 4 by 9 whole to the power of plus 3 by 2. So, when this is taken to the numerator, so if you interchange these values, 9 by 4 is also equal to reciprocated. 4 by 9 to the power of minus 3 by 2 becomes plus 3 by 2. So, this can be written as 4 by 9 can also be written as 2 divided by 3 whole square whole to the power of 3 by 2. So, again if you apply law of indices, 2 by 3 whole to the power of, so this is 2 by 3 whole to the power of 3 by 2, 2 2 gets cancelled. This is 2 cube, 2 cube is 2 to the 4 to the 8 divided by 3 cube is 27. 8 by 27, which is the required answer. You can simplify like this, that any method you follow to simplify this. Hope you followed. Now, let us come to the next problem. Now, simplify a to the power of x plus y into a to the power of 2x minus y. Very simple problem. Now, what is given here? Given equation a to the power of x plus y into a to the power of 2x minus y. This is using law of indices. A raised to m into a raised to n is a raised to m plus n. This is a to the power of x plus y plus 2x minus y. This is a to the power of minus y plus y gets cancelled. X plus 2x is a to the power of 3x. That's it. A to the power of 3x. Okay. Now, let us come to this problem. See here, a to the power of m plus n into a to the power of 2m minus 1 divided by m minus n. Now, in the numerator is of the form a raised to m into a raised to n is a to the power of m plus n. We can apply a to the power of m plus n plus 2m minus n divided by, in the denominator, a to the power of m minus as it is, minus n plus n gets cancelled. A to the power of m plus 2m is 3m divided by a to the power of m minus n. Again using second law of indices, a to the power of m by a to the power of n is a to the power of m minus n. This is a to the power of 3m minus m, minus into minus plus n. This is a to the power of 3m minus m is 2m plus n. So, this is a to the power of 2m plus n is the required answer. Okay. Let us come to the next problem. Simplify x to the power of 1 by 2 plus y to the power of 1 by 2 into x to the power of 1 by 2 minus y to the power of 1 by 2. Now, if you observe carefully, this is of the form a plus b into a minus b. What is this equal to? A plus b into a minus b is nothing but a square minus b square. A square minus b square formula is a plus b into a minus b. So, the given equation can also be written as x to the power of 1 by 2 into x to the power of 1 by 2 is x to the power of 1 by 2 whole square minus y to the power of 1 by 2 into y to the power of 1 by 2 is y to the power of 1 by 2 whole the square. Again, using this law of indices, a to the power of m whole raised to n is a to the power of m into n. So, this can be written as x to the power of 1 by 2 into 2 minus y to the power of 1 by 2 into 2. 2 gets cancelled. X power 1 minus y power 1 is nothing but x minus y, which is the required answer. That's it. Very simple for 2 marks. X minus y is the required answer. Now, let us come to the next problem. This is very important for 3 marks. This is a 3 marks question, very important. Prove that x to the power of a plus b by b minus c whole raised to a minus c into x to the power of b plus c by c minus a whole raised to b minus a into x to the power of c plus a by a minus b whole to the power of c minus b is equal to 1. Now, very simple. Let us take LHS. What is LHS? LHS, x to the power of a plus b divided by x to the power of b minus c whole to the power of a minus c into x to the power of b plus c divided by x to the power of c minus a into b minus a into x to the power of c plus a divided by x to the power of a minus b whole to the power of c minus b. Now, let us apply the first formula first. A raised to m by a, second formula, a raised to m by a raised to n. A to the power of m by a to the power of n is a to the power of m minus n. This can be written as x to the power of a plus b minus into minus plus whole raised to a minus c into x to the power of b plus c minus into minus plus a whole raised to b minus a into this is x to the power of c plus a minus a plus b whole to the power of c minus b. Okay. Now, this is equal to x to the power of, just see, minus b plus b gets cancelled, a plus c whole raised to a minus c into x to the power of plus c minus c gets cancelled, b plus a whole raised to b minus a into x to the power of minus a plus a gets cancelled, c plus b whole to the power of c minus b. Now, again using this law of indices, a to the power of m whole raised to n is equal to a to the power of m into n. This can be written as x to the power of a square minus c square into x to the power of b square minus a square into x to the power of c square minus b square. A into a is a square minus c square, b into b is b square minus a square, c into c is c square plus into minus minus b square. So, the using first law of indices, a raised to m into a raised to n into a raised to p is a raised to m plus n plus p. So, bases are same, we can add the powers, x to the power of a square minus c square plus b square minus a square plus c square minus b square. What happens? Plus b square minus b square plus c square minus c square plus a square minus a square gets cancelled, x power 0, that's equal to 1, which is the required RHS. So, x to the power of 0, that's equal to 1 is the required answer. That's it. Hope you followed. Now, let us come to the next problem. This very simple problem, as I already told you, cube root of x is nothing but x to the power of 1 by q. So, cube root of x to the power of p is also equal to x to the power of p by q. So, based on this, we are going to simplify this. The given equation is cube root of x square whole cube whole to the power of 1 by 2. Now, this is, you just keep this 1 by 2 as it is. Cube root is nothing but x square, cube root is nothing but whole raised to 1 by 3 whole to the power of 3. Here this 3 and 3 gets cancelled. What you will get? X square, 3 and 3 gets cancelled. X square whole to the power of 1 is x square whole raised to of. Again square and square gets cancelled. That's equal to x. That's it. Using this law of indices, a to the power of m whole raised to n is a to the power of m into n. So 1 by 3 into 3 is 3 gets cancelled. X square whole raised to 1 is x square whole to the power of 1 by 2. Again 2 into 1 by 2, 2 and 2 gets cancelled, x power 1 is equal to x. So the required answer is this is equal to x itself. That's it, very simple. Okay. Let us come to the next problem. Simplify a to the power of 2m plus n into a to the power of 3m plus n divided by a to the power of 4m plus 2n. So the given equation can be written as, what is the given equation? A to the power of 2m plus m into a to the power of 3m plus n divided by a to the power of 4m plus 2n. Right. Now here using first law of indices, a power m into a raised to n is a to the power of m plus n. Use the first law in the numerator, a to the power of 2m plus m plus 3m plus n divided by denominator is same, a to the power of 4m plus 2n. So a to the power of 2m plus 3m is 5m plus n plus n is 2n divided by a to the power of 4m plus 2n. Again using second law of indices, a raised to m by a raised to n is a to the power of m minus n. So a to the power of 5m plus 2n minus 4m multiplied by negative sign minus 2n. Plus 2n minus 2n gets cancelled. 5m minus 4m is plus m. So the required answer is a to the power of m. That's it. Okay, very simple. Apply first and second law, you will get the answer. Okay. Now let us come to the next problem. Same type problem here. Instead of into, it is plus 2 to the power of n plus 1 plus 2 to the power of n minus 1 divided by 2 to the power of n plus 2 to the power of n plus 2. See the difference between first and this problem. Here it is into, here it is plus. So since we know this, what is the formula for a to the power of m plus n is also equal to a to the power of m into a raised to n, or a to the power of m minus n is also equal to a power m into a raised to minus n. So the given equation can be written as 2 to the power of n plus 1 is 2 raised to n into 2 power 1 plus 2 to the power of n into 2 raised to minus 1 divided by this 2 power n plus 2 to the power of n plus 2 can also be written as 2 to the power of n into 2 square. So in the numerator we can take 2 power n common factor. What is left over is 2 to the power of 1 is 2 plus 2 to the power of minus 1 divided by, in the denominator is also 2 to the power of n common factor, 1 plus 2 raised to n is gone, 2 square. Now these two gets cancelled. This is equal to 2 plus, what is 2 to the power of minus 1? That's equal to 1 by 2 divided by 1 plus 2 square is equal to 4. Take LCM in the numerator, 2 is LCM. 2 into 2 is 4 plus 1 divided by 5. So what is there in the numerator? 5 divided by 2 whole divided by 5. 5 divided by 2 whole divided by 5. This can also be written as 5 by 2 into 1 by 5. That's equal to 1 by 2. The simplified answer is 1 by 2. That's it. Okay. Now listen to me here. So given equation can be written as 2 raised to n into 2 raised to 1 plus 2 to the power of n minus 1 is 2 raised to n into 2 raised to minus 2 split. Again denominator 2 raised to n as it is, 2 raised to n plus 2 is 2 power n into 2 power 2. In the numerator we can take 2 power n common factor, denominator also 2 raised to n common factor, 2 power 1 is 2, 2 raised to minus 1 by is 1 by 2 divided by 1 plus 2 square is 4, 2 2s are 4 plus 1 is 5 by 2 divided by 5, take this to the numerator, 5 by 2 into 1 by 5, 5 gets cancelled, we will get 1 by 2 as a simplified answer. Okay. Now let us come to the last problem. Very simple problem. Simplify this. This is also important for 3 marks. What is given? X by a, x to the power of a divided by x to the power of b whole raised to a plus b, x to the power of b by x to the power of c whole to the power of b plus c, x power c by x power a whole to the power of c plus a. This is very simple problem. Given equation is using this formula. First, a raised to m by a raised to n is a to the power of m minus n. This can be written as x to the power of a minus b whole raised to a plus b as it is into x to the power of b minus c whole to the power of b plus c into x to the power of c minus a whole to the power of c plus a. Now again this is equal to x to the power of law of indices. Third law, a raised to m whole raised to n is a raised to mn, a square minus b square into x to the power of b square minus c square into x to the power of c square minus a square. Now again using law of indices, first law, a raised to m into a raised to n into a raised to p, a raised to m into a raised to n into a to the power of p is equal to m plus n plus p, a to the power of m plus n plus. So the bases are same, x to the power of a square minus b square plus b square minus c square plus c square minus a square. This is equal to x power plus b square minus b square plus c square minus c square plus a square minus x square gets cancelled, x power 0. X to the power of 0 is nothing but 1. The required answer is 1. That's it. This is how we are going to simplify. Very simple, very easy and very important type of problem. Okay. So this is how we are going to solve the problem. So these are the problems. That's all regarding this session. So in this session we have studied the laws of indices and a few basic problems based on laws of indices. That's all regarding today's session. Let us meet with a few more concepts in the next session. Thank you very much.